Hello, and welcome to EPR with your favorite environmental nerds, Nick and Laura. On today's episode, Nick and I discuss math, English, and how they relate to the joys of coding. Get ready for that one. Then we talk to Chelle Gentemann, a senior scientist at Farallon Institute, about coding, open science, and rugby. It's really such an awesome listen, so make sure you stick around for the fun parts, and which is all parts, of course.
It's all parts. Yeah. It's all fun.
And finally, the moon is constantly moving further away from the Earth, and that will eventually mean that we won't have any tides. Wow, that's weird. Mm-hmm. Of course, by then, the sun will be a red giant so large that it will begin to disintegrate the Earth. But hey, this is what Nick wants us to know today.
The dark start.
We can only go up from here, folks. Hit that music.
Our shout out for today goes to Callie Wielenturf. She was just on episode 54 of the show discussing rights of nature in Panama, and we are so thrilled to announce that on February 24th, 2022, the President of the Republic of Panama signed the Rights of Nature Act into law. Article 1 of that law states, among others, nature is the subject of rights, and the state and the people have the obligation to protect and respect these rights. Some of the rights of nature have been recognized include nature's right to exist, persist, and regenerate her vital cycles, among many others. It's super cool. Really, really awesome that got through. And you should go listen to the episode. It's a really, really good one. And congrats to Callie for helping make that possible.
That's awesome.
It really is. We appreciate all of our sponsors, and they will keep the show going. If you'd like to sponsor the show, please head on over to www.environmentalprofessionalsradio.com and check out our sponsor form for details. Let's get to our segment.
Coding is awesome. I love it. I'm hoping that, so I have my GitHub page, and I'm very proud of my GitHub page that I built myself, but I didn't get any farther than just making the landing page. So,
well, I mean,
every round of careers in code that I coach, I can still sit on a classes. So I'm going to keep trying. Maybe in a couple of years, I'll get a little further.
Go. I mean, it's funny though, because her brain, Chelle's brain works exactly the opposite as mine. And we had that little debate about science, math versus English. And it's such a good one. Like, I love that. Like, where she's like, well, math has the answers and there's no BS. It's just, This is the answer. And I hate that. I very much love the BS part, And so,
that's true. I get down with the BS part myself.
But her perspective is, that's hard for me because there's nothing I can just say when I, what the right answer is.
That makes sense though.
Yeah, it totally does.
You can't argue with that logic.
No. But, it's like, I love trying to figure out how I can get us to agree on something, even though I know there's no right way to do it.
You're full of snot.
Full of snot? What?
I'm not saying the S word.
Oh, yeah. Mm-hmm. Yeah, exactly. Full of snot. Oh, that was fun. I was like, oh my God, my nose is running or something. That's what I thought. I was like, I got tissues right here. I'll just.
Yeah, but I'll say you don't really need to know math to do coding, though. You need to know math to do the level of coding and the NASA stuff she's doing. You don't have to know math to be a coder. Mm. Otherwise, I would never have started on that.
That's what I mean. Yeah, I was going to say. She said it's more like learning a language, right? So it's not necessarily math related.
It is, and it's once you learn one, because in today's world, you can't really just like learn one programming code and then you know how to build stuff. You have to integrate with other coding languages. Like she said, I added on Python at some point. Right. And then you have to work in a lot of different ways getting them to speak to each other. But once you learn one, there's kind of like two different. It's almost like Chinese and Spanish. There's different languaging frameworks, but once you learn the Spanish type ones, you can easier learn the English ones and the ones that are related. And same with Chinese. You could learn like Mandarin and then learn some other
like Cantonese and such.
Related ones. You can do that with programming too. So it's really fun. It's kind of like a game. So if you like being able to solve puzzles, which she kind of said, once you kind of figure out that it kind of works the way math works and like X plus Y equals Z, but you don't have to like necessarily make things add up.
Right. Yeah. And I think, like you say, coming at it from different angles and, you guys have different personalities and different interests, but you still both like doing it. then that means, it may be more universal than people think.
Yeah, absolutely. Like I said, it's just fun. It's fun to like put some words, strings of words and letters together and go like,
yeah.
Look at that website.
Execute. Yeah.
Or, you hit a button and then 10 things happen instead of just one step at a time or whatever. It's pretty exciting. So I can't imagine how addicting that would be to get to that level.
Yeah. And I mean, I will admit, like when I was in grad school, I did enjoy like doing our version of that, the free program stuff.
Yeah.
But like, it's just, I mean, I knew it wouldn't be something I want to do forever, but yeah, the execute part is great. You're like, did I do this correctly? And you're like, oh no, I didn't. Okay. But no, that's pretty neat.
For me, it was like when she described the way her kids described her job. When I was 20 years old in programming, I was like, I don't want to sit in front of a computer 24/7. But now, like, fast forward, like, pretty much my day looks like her day. So
I know.
I could have.
You talk to your friends.
But it goes back to not having those role models. I didn't have someone like Chelle in front of me to say, actually, the programmer I worked for was a woman, but she was, and this is, of course, I was in Tampa at the time and then moved to Ireland, but she was a hardcore New Yorker. She smoked. She thrived on chaos. She seemed like a legit crazy person. She was great. She was super nice and friendly and helpful, but she made her own world crazy. And I was like, I don't want to be like that. That was my role model for like what happens to you if you become a programmer, Right. And I was like, no thanks. On the other hand, my dad worked for like IBM and he was always learning new technologies and different things. And I don't know if he did any programming type stuff, but he got laid off all the time. And I was like, oh, I don't want that either. The world had not really gotten to where it is now, to where like in tech jobs are like in crazy demand at that point back then, they were, it was a different situation. So we have to get these role models out here. And that's why I think it's great to have Chelle on. And I hope to have some other programmers and people doing cool, fun tech environmental jobs, because that's the future, really.
But yeah, I guess we've talked long enough about that. Let's hear from her. All right, let's go to the interview. Hello and welcome back to EPR. Today we have Chelle Gentemann on the show. She is a senior scientist at the Farallon Institute and is one of the most brilliant minds we've had on the show. She is leading research in open science, cloud computing, remote sensing, and physical oceanography. Welcome, Chelle.
Hi, Nick. Thanks so much for having me on.
Yeah, absolutely. Really happy to have you on here. And just a little bit of background for everybody. You attended the Massachusetts Institute of Technology. Sometimes they refer to that as MIT. I don't know if you guys have heard of it. You have a BS in Earth, Atmospheric, and Planetary Sciences. Then went on to the Scripps Institute of Oceanography and received a master's in physical oceanography, and then received a PhD while working full-time for the University of Miami's Rosenstiel School of Marine and Atmospheric Science. That's pretty impressive stuff.
That's a lot of years of math.
So, I mean, like I say, our first very hard-hitting question for you here. How did you get started on that path? Like, what were you into as a kid?
I grew up in the Pacific Northwest. So I lived in Portland, Oregon, right outside it with my parents and my sister and brother. And we had grandparents up in Seattle. And we just always were at the coast fishing and exploring. And that's how we spent our summers up in the Puget Sound. So I had this really close connection with nature and the ocean, I think. And then I also had this just immense fascination with math and science. And so from a young age, I've always wanted to be a scientist, and I was always interested in the ocean. There was a movie that came out in, I think, the early 80s called Space Camp. So I did have a 2-year phase where I wanted to be an astronaut.
I remember it. Oh my gosh, that's funny.
And now I've managed to combine them because I work for NASA doing Earth science.
That is so cool. That is
Which is amazing.
So
cool. Who would have thought you could do that?
It's all because of that movie.
Oh, that's so funny. Oh man. Yeah. I love that movie.
Love that movie.
Right in my brain. Yeah. Which is just great. And I think, it's funny. You say you fell in love with math. Was that a love? Is it literally always been a love for you? Or is there ever like times where you're like, you know what? I know there's an answer to this, but it's driving me crazy.
Yeah, I think everybody hits that point at a different point in their life.
Mm-hmm.
for me, I found English really frustrating and writing to be really frustrating because there wasn't this answer. I wanted to be able to say, this is for and this is right. And with English, I felt like it was so subjective. Sometimes I really struggled with that. I needed a clear answer. Mm-hmm. And so English made me think harder, I think. And so I leaned towards math, which in some ways, to me at least, the way my brain worked seemed simpler. But I think no matter what topic you choose, at some point you reach a place of just utter loss and confusion. For me, that was when I took a class on imaginary math. And I know it doesn't sound real, but it actually is. And I do. I remember just sitting there going, I don't even understand what this person's saying. I can't put it into anything that I can relate to. And so I reached out and I got help. I reached out and I got tutors and I started talking to the professor. And that was how I sort of learned how to overcome these barriers that you run into throughout your whole life, is trying to find community and friends to help.
But okay, tell us how that kind of ties into your work now that you're doing now with Farallon Institute.
So with the Farallon Institute, I sort of switched up how I was doing science. I had been working for about 20 years on what we call satellite algorithm development. And what that means is when you take a measurement at a satellite in space, you're actually using an instrument, like you take a thermometer to measure temperature. Mm-hmm. The instrument on the satellite measures photons. How do you turn a photon into a measurement of ocean temperature or wind speed or clouds or something that people can use to understand Earth's climate and weather? And so that's what I worked on. And it was really fun and interesting and rewarding. And I loved it. And then as I got to the Farallon Institute, I started thinking about, I've been hearing about this new language called Python. Mm-hmm. And I decided to try and learn it. I guess I'm somebody who, the minute I know something, then I need to find the new thing to learn.
Yeah, absolutely. 100%.
So I went down and took some classes and started learning how to program in Python. And then as I started getting comfortable with that, I wanted to really do big data analysis. And so I started moving on to cloud computing, which is where you actually, instead of taking data and bringing it to your local computer, you take your analysis and you bring it to a cloud computer. It's the same thing you do with Google Drive when you access a document on Google Drive. You're just going to the cloud. Mm-hmm. And that sort of changed everything that I started doing at the Farallon Institute, and bringing the open science and the cloud computing together really crystallized a lot of thoughts about science in my head, because for a long time I had struggled to work with colleagues. Because if I was at the Farallon Institute and they were at, UC Berkeley, or they were at University of Washington, how do I work with them? Because they're on a different computer system. Mm-hmm. Yeah. And how do you do that? And the cloud was actually the answer to doing that. It made it easier, and working in an open source and open science way made it easier to do that. But I was struggling to work with all my colleagues who I'd worked with for 20 years who were doing the algorithm development, because they didn't know how to do the open science part yet. So as I've been working at the Farallon Institute, I've been working to try and connect those two groups.
Wow, that's super cool. Mm-hmm.
That's also a perfect segue into our next question. So, we wanted to jump right into NASA as quickly as possible. So you're the lead researcher on the NASA's Transform to Open Science project. But, I'm certainly familiar with open source data, but what is open science and why do we need it?
That is exactly what I was just talking about. There's a lot of scientists who have been doing science for 20 years. And the way that we've been doing science has been very siloed. It's been very closed, because we've all been working on our individual computers. And maybe those individual computers are at a big institution and you're on an institutional network, but then you only have access to work with other people at that institution. And that means that you can do that easily, but trying to work with somebody at a different institution is difficult. So NASA has started a new initiative called the Transform to Open Science, and it's about trying to increase the understanding and adoption of open science practices and broaden who's participating in science. So I define myself as a scientist, but not everybody who does things similar to what I do maybe defines themselves as a scientist. So how do we try and really increase participation in science by all different types of people? And one way to do that is to be really transparent and open about what you're doing and how you're doing it. And that way, if somebody can see it and touch it, then maybe they reach out to you and they start collaborating with you. And they can come from a totally different background, but they can see your work and ask questions and start to interact. And that's the first step to sort of increasing who's participating in science. And one of the goals of TOPS is we're really facing these big problems like COVID and finding the vaccine really fast and climate change. I mean, we have a climate crisis that we have to figure out how to address and maybe start mitigating some of the impacts. So we need all of the voices at the table participating and asking questions so that we get the best solutions. Because if there's only a few people at that table, they're going to find really great solutions that work for them.
Right.
But the impact of those solutions isn't as big as it could be. So we have to broaden who's participating in science, and we have to do it in a way that's transparent and inclusive and open.
That's great.
That's the cool answer. That's awesome.
I'm going to give a shout out to the Water Atlas, which is a group that works at USF, the University of South Florida. And this is what they do on a regional scale. But part of what they do is, like you said, one university, one scientist is collecting data one way on one computer. Someone else, we all know that our Androids and our iPhones don't play nice together. So if I'm using one software to collect my data or a completely different brand than someone else, then we have data that doesn't talk to each other, no matter how much we want it to play nice together. So does the TOPS project, so if I come to TOPS and say, hey, I've been collecting this data, they've got almost 50 years of ambient water monitoring data in the Tampa Bay area. And, regionally you can get it. Anybody can go download it. But if they wanted to contribute to this project, is NASA or engineers there the ones that are converting that data to make it work together? Or how's that working?
Well, there's two ways to think about that, at least in my mind. And one is the data in a format that's called FAIR? Is it findable, accessible, interoperable, and reusable? And that means that the most amount of people can use it because it's in a format that is accessible. It has metadata that describes what's in the file. So if it's in a good format, that makes it much easier for lots of different people to use it. So then you have to get it to a location where everyone can access it. That's often whoever has funded the collecting of that data. Hopefully that funding agency has planned for a long-term archive of that data that is publicly accessible, and they support that archive to increase accessibility. So what NASA has done is NASA has in the earth science, as well as planetary, astro, helio, and biological and physical sciences. So all the different divisions have data archive centers that store all the NASA data that's collected. And traditionally, what's happened is scientists or anyone who's interested goes to that data archive and they download the data. And that sounds a little bit like what's happening with your Water Atlas data. Is you have to figure out where it is. First of all, you have to know that it exists.
Right.
And once you know it exists, you have to figure out where it is and then how you can get it. So part of the Transform to Open Science is supporting sort of the cyber infrastructure and the software that makes that easier to discover data, easier to access data. The more that we can sort of hide behind the curtain and be the Wizard of Oz, right? So we want to hide the format. We want to hide where it is. We want to hide everything about the data that we can, except what it is, what it means, and then just let you access it. So part of transforming to open science is also increasing the accessibility of that data. And sometimes it can remain on a local archive, but often it's easier and more accessible if it's moved to a cloud platform with free egress so that people can get at it for free. And it makes any work you do with it, if you do that, it makes it more reproducible, because then people can write notebooks that other people can just run.
Yeah, that's fantastic. And like you said, it makes all of the data more powerful, as long as the data that's coming in is quality. So where's the quality assurance come in?
It's really interesting. I've not actually seen any data that's perfect, right? Everything has imperfections, and that's what makes it beautiful. That's why we all have jobs.
Right.
So even data from instruments can have calibration issues. And if you go out into a field and take observations, you could copy something down wrong, or you could not realize that you're in the shadow of a tree, or, there's all sorts of uncertainties in data. And one of the important things to capture when you create a data set is the uncertainties in your data. And you can do that statistically, but you can also just do that by providing metadata that sort of records, here's where the data is good, here's where the data is bad, or you could have flags in your data. The more information that you can embed in your data about how to use it accurately, the better off it's going to be when it's used by people who don't have access to you to answer questions.
Awesome. Right. So people shouldn't be afraid to add their data and put it in there. But I would like to know too, so I would guess that you're one of those persons that when people say, so Chelle, what do you do? You get the follow-up question, so what do you do? when people ask you, what do you do? Do you tell them you're a physical oceanographer, or what's your response to, hey, Chelle, what do you do?
Depends on the audience. If you ask my kids, this was a downside to COVID, right? Is my kids found out my secret. They stayed home from school. And so they were able to see me work all day long. And by a few months into at-home schooling, we had this conversation where we were like, okay, it's important that you focus on school. School is important. And he's like, no, school is really hard. And you don't understand, because all you do is sit on your computer, talk to friends, listen to music, and laugh while you code. And you have it so easy, you don't even understand. So for kids, basically my job description is, I hang out on my computer, I listen to music, and I talk to friends.
That's a good one.
For scientists and other adults, I usually say that I'm an oceanographer. I study the sea from space.
Such a cool phrase.
That's a very great way to explain that.
Because it's hard, right? If I start talking about photons and instruments and petabytes of data and software and Python and cloud computing, it's not very accessible. And it's not very realistic, because my job is to think about things and try to be adventurous and creative.
That's awesome.
And I think that's like a really great job to have, is to just sit and ask questions. I'm like the 2-year-old that never got over the why phase.
Yeah.
That's perfect. So how does a young person who wants to do something to fight climate change or have a responsible job like that, and maybe it's just that they enjoy math, but how would someone identify that this might be a path that they would like to be on?
I think that there's a lot of sort of mystique about coding, that you have to be this genius wearing a hoodie, sitting in the dark, typing away, drinking coffee, and not talking to anybody. But I think, as I just described from my kids' description of my job, that's not really the way it is. Coding is very community. And when I have questions about it and I can't figure something out, I just ask, and then I get all my friends to help. It's a very friendly, collaborative process. So for people who wanted to get into like climate change and studying the earth and weather and climate, or understanding what's going on at their house or in their environment, or especially using Landsat imagery, maybe of the local area to find where things are flooding, or to look around at your environment, the best way to do that is to just start learning how to code. And there's lots and lots of different local coding groups that you can join. And I think it's really key that when you start to learn something, if you can learn it at school or in a club. And then you can also join other clubs or take an after school class or a summer class. And it's going to seem really hard at first because it's almost like learning a new language. But there is, I think with coding, at least for me, and I think I've seen this with a lot of other people, there's like a couple months into it, all of a sudden you realize it's just another way of talking. And then once you learn the syntax, it's like learning how to drive. And so the first couple times you're driving, you don't know where the turn signal is. The brake and the accelerator, you get those mixed up and it's just confusing. And then after you've driven for a couple of weeks, all of a sudden you don't even have to think. It just seems really natural. And I think coding can be really like that for lots and lots of people. You don't have to be a mathematical genius. All you have to do is like solving problems. So if you like puzzles, if you like crosswords or just thinking about things and finding solutions and solving little problems, that's what coding is. And once you solve little problems, then you can go online and there's all sorts of hackathons you can participate in. There's all sorts of summer schools and people posting notebooks that you can start looking at NASA satellite data yourself and downloading it. There's big space app competitions. So there's a lot of opportunities if you start Googling NASA and coding and space apps, or even GitHub and coding that allow you to interact with other scientists and also other people and kids who are learning how to code. A really great way to get into science is to start doing science Twitter or Instagram or TikTok. And I think you should be very careful as a young person to have a separate personal account and then perhaps a more professional account. But there are all types of scientists, but science is mostly on Twitter right now, but there's starting to be some on TikTok and Instagram. And you can start following different scientists that you like. And a lot of them post about resources or they post notebooks that you can then reproduce their results. And that's another fun way to start talking and thinking about doing science.
That's awesome. That's really great advice. I see Nick is smiling. He's like, I'm going to follow some.
I'm going to do that right now.
Raven the Science Maven is like one of my favorite. I don't know if you've ever followed her. She does. Oh, she's amazing.
Oh, that's awesome. Yeah, we will now.
Really awesome. And that again,
stay in the science Twitter. Don't go to the other side.
The dark side of Twitter. Yes,
I know. That's just scary.
Don't go to the politics side. Stay in the science. That's awesome. So, and it again leads right into the next question. So, these technologies, they change quickly. And they kind of subtly change quickly. Like all of a sudden we have cloud and that changes the game for everything. And you mentioned GitHub. You can go on GitHub and start grabbing other people's code tomorrow once you figured it out. And so how do you keep up with all of the changing technologies and know like what to chase after and all of that?
Yeah. So technology is changing so fast. And the way that we do science and how we communicate about science is changing just along with that. So 10 years ago, the way that scientists communicated their results was they would maybe go to a conference with other scientists and they would give a slide presentation and then they would go home. And then they would write that result into a publication and then they would publish it in a scientific journal that was usually behind a paywall. So you couldn't access it unless you went to a university library or downloaded it at a university and you had access to it. Otherwise, you had to pay. Now, the way that science communicates and the way that we keep up with technology is through social media and through the internet. So there are sites like Medium where people are publishing results and they're just doing it informally and really interactively. They're writing up what they're working on right now and publishing it and why it's exciting or some new tool that they learned about and why they think you might be interested in this. So, blog posts, Twitter is probably where I get most of my information and people are posting their research notebooks and I often click on them and then try to see if I can reproduce their results or if there's something that's of interest to me. Like people are like, hey, do you know about this software library? Or did you know about what you could do on this platform? And so science is really starting to be communicated through software notebooks like Jupyter Research Notebooks, because in these research notebooks, it's almost like a publication with the code to reproduce the result. And so when people write up these nice Jupyter notebooks, you can use markdown language, which is just text basically, and you can describe exactly what you're trying to do. And then you have the code where you try to do it. And then you write a bunch of markdown code that says this didn't work and this didn't work, but I'm going to try this. And then eventually you get to a result. And that's the way people are starting to communicate a lot of their science. And then they publish it on social media and everybody else learns about it. So things are changing. And it's still the journals are the respected source for when you get to a final result. But even those journals are starting to get faster and faster in how they publish things.
Yeah, that's really interesting to hear too. And, you know, science is supposed to be a collaborative process. And, but like you said, the previous way we were doing things kind of limited who we're doing that with. So when we're talking about being collaborative, you're talking to people online, I'm sure that the scientists get information and from all kinds of different sources. Then you go back to a journal and you're like, well, I got a lot of my information from these 3 people and also Twitter. So, I mean, how do we categorize who's actually helping?
A lot of times when I'm working with different people, I'm working in some sort of notebook. And if I'm working collaboratively on GitHub, you can see exactly who's contributing what. When I'm working in a document, I always have a little text part at the end that if you do anything in this document, please write down your contribution, because it's hard to keep track.
Right.
And you want to make sure that you give everyone proper credit. I think it's also interesting the way that a lot of collaborations are starting to move to GitHub. So Git is the software that you use to version control code. Mm-hmm. GitHub is the website that you go to you can publish your code, you can keep it on the cloud, but GitHub also has discussions and all sorts of project management. So a lot of scientists now are being really collaborative by being very open about what they're doing, publishing their code and their notebooks all on GitHub. And then other random scientists find it via a search engine and comment on it or correct a sign error. And then they start this whole new collaboration on GitHub, which has really been, it used to be that when you had a problem, you would email another scientist. And then you would start this sort of closed communication where only you and your friends could talk about that topic. When you open that up and you start having that conversation on GitHub, it means that Laura, who you and I weren't talking to, Nick, Laura could find what we were talking about and say, hey, I think that's really interesting. They're talking about the water atlas. And I know about that. So I'm going to add some comments. And then all of a sudden we're working with Laura too.
Right. Yeah. And I think that's awesome. And thank you for taking us through that. And it's such a cool thing. And I love that that's where we're going. I think it's fantastic. So we do have a part of the show where we like to talk about field notes and where we have our guests tell interesting stories about things that have happened in the field. And I think for you, maybe it's more of a field story from a conference room. But you mentioned giving presentations and going to those kinds of things. But do you have a funny moment about you giving a presentation to a room full of people?
I feel like you might be setting me up to tell a story. You told me not to use bad words, so I won't use bad words. I know.
You can just say, shite or shizzle or smurf or something.
Yeah. So at I think it was only the second or third talk I had ever given at a scientific conference. And I had these really exciting new results. And I was really nervous and I was scared about talking in front of people. And usually you're in a small room with about, 15 or 20 people. And they put me in the big main session. So there were 300 people in the room. And I was shaking. I was so nervous and scared. And I got up to give my talk. And it was also, I think it was only the second time I had ever given a talk from a computer. All my talks previously had been from actual transparency slides.
Right.
So for the younger generation that don't know what those are, is before PowerPoint, you had a clear pieces of paper and you would write on them, or the new advantage was you could print on them. And so you would put each slide onto an overhead projector, and that's how you would give your talk. So I had moved to a computer and I didn't really know how to use it. And the first thing that happened was I put up my title slide, I introduced myself, and then I hit the arrow bar to go to the next slide, and it didn't go forward. And I freaked out. I didn't know what to do. And they had mic'd me, so there was a mic right below my chin. And as I leaned over to the laptop, I said, "Oh," and a word that starts with S that's not, I shouldn't say. But I said it about a millimeter from the microphone. So it came out as if I had yelled it to the entire audience.
Right.
And I remember just looking up with my eyes as big as I just thinking, and everyone just bursting out in laughter.
Of course.
And I was so embarrassed, but it ended up being this fun thing, because then everybody came up and introduced themselves afterwards. And it was really a great moment, because I met all the different scientists at the conference, and I was very approachable at that point because I had been the one who messed up.
Oh, that's so awesome. Funny. Yeah.
Yeah,
we've all been there. Yeah, exactly. Yeah. Well, she's already embarrassed herself. There's nothing I can do that's worse than that. I might as well go say hello, right?
Yeah, exactly. That was their we should get to know this woman and see what she does next. It's going to be a train wreck. Let's just follow her around.
Yeah. Oh my gosh. Yeah, that's
and those are things now that you're like, oh, I'm glad that happened before cell phones.
Yes.
Yeah. Yes. Oh yeah. Infamy. Yeah. But it's funny. I want to ask you, if you do something besides research and coding for fun, but I'm worried that you do coding, and that is what you do for fun. But what do you do to unwind? What else do you do?
It's true. I do coding for fun, and that is my happy place. But our whole family, we go mushroom hunting.
Oh, nice.
So we go out into the forest in the middle of the winter when it's all rainy and beautiful, and we go hunting around for mushrooms. So that's really fun. We also do a lot of hiking together. I really like the outdoors. So we do hiking and skiing and spending time with my kids and my husband. Outdoors. I love the outdoors.
That's wonderful. You also seem very soft-spoken and very approachable and all that. So we discovered a little fun fact. Little Birdie told us that you might have played rugby for MIT.
Did you find that
out? Character for you. Is this true?
I was the team captain.
Oh my God. That's amazing.
Oh man, you have to tell us about that.
I grew up in Oregon, right? You're supposed to run around and play soccer in the mud.
Mm-hmm.
And rugby was sort of the next extension of that. You run around and it's very social. That was what I loved about rugby. I think that's why I started playing rugby was you got to, and this was in Boston. So it was like cold and muddy and wet, and we weren't that good, but we had a lot of fun. And the thing about rugby that I loved was when you play rugby, you get to run around and be athletic and outside, and it's really fun just to play a sport.
Mm-hmm.
But rugby has this tradition that the teams get together afterwards and hang out. And so you got to meet all these different people. And you sing rugby songs and you sing together and maybe have a beer. And it was really fun.
That is so cool. Oh, man.
Did you find that out?
We have a super, super research team.
Yeah. But, well, I mean, it's a great spot. Like I say, thank you so much for spending your time here. We know you have a lot going on. So we're coming close to the end. Is there anything else you'd like to touch on before we let you go?
I think I'm great. I really appreciate the time to talk to you all. And for anybody in the audience who would want to learn more about open science, they can just Google NASA Transform to Open Science. And we have both a webpage, we have a GitHub site that you can actually ask questions on and interact with scientists. So if there's anyone who wants to reach out, we're going to be having lots of hackathons and it'll be really fun. We want everyone to participate. So our tagline is especially for open science, for NASA studying the Earth, studying weather and climate change. We want to change everything. You need everyone.
I love that. That's awesome.
And that was from the older climate change movement. So the climate change movement sort of coined that phrase. To change everything, we need everyone. And I think that holds true for everything. So if you want to try and do science and you want to do open science, we want everyone to participate.
Yeah, that's great. Absolutely. And if people wanted to get in touch with you directly, is there a place where they can?
Yes, I have a Twitter account. So my Twitter handle is just my first and last name, Chelle Gentemann. And I also have a website, which is cgentemann.github.io.
Perfect. Well, Chelle, thank you so much for being on the show. It was an absolute pleasure. We had a lot of fun. Thank you.
Thank you. This was really fun.
That's our show. Thank you, Chelle, so much for joining us today. This was really awesome. It was so much fun to be around not only your brilliance, but your great attitude and lots of laughs. So be sure to check us out each and every Friday. And don't forget to subscribe, rate, and review. Bye.
See you, everybody.